This conference will now be recorded. This conference will now be recorded.
So, very good evening, students. Today we are continuing with discussions on the JEE previous year's questions on kinematics chapter. So, we have few important questions today. So, these are all various years questions, previous year's questions from JEE mains paper. So, today we'll actually concentrate on mainly various projectile problems. So you can see one problem is here. So the first problem is saying that a plane is inclined at an angle alpha with respect to the horizontal. So you can see this is the plane, inclined plane, and the angle of inclination is 30 degree with the horizontal. A particle is projected with the speed 2 meter per second from the base of the plane, making an angle theta with respect to the plane as shown in the figure. See, this angle is actually with respect to the plane. This angle is also theta. This is theta, sorry, 30 degree. This angle is called theta, but this angle is with respect to the plane, inclined plane. Now the question is the distance from the base. Base means here. This is the base, starting point. The distance from the base along the inclined plane at which the particle hits the plane is close to 20 centimeter, 30 centimeter, 18, 14. You have to find out the answer. That means the range along the inclined plane. So look here, this is not a very common problem what we do in textbook. In general, in textbook we know a projectile is projected some angle theta, like that we know. Then you can take g as constant, and here u sin theta, and along horizontal direction u cos theta. Since gu always g, so g, the gravity always acts in this case, g always acts in the vertical direction, so this will be constant of motion or uniform motion, horizontal direction, in horizontal direction. So in this case what we do generally, we find out what is the time of flight, and then we multiply u cos theta into time of flight. Okay, by doing that we find out the range. Okay, but here if you just mark up the formula like u square sine 2 theta divided by g, this is not going to work anymore in this inclined plane. So you have to actually make certain modifications. We'll now try to understand how to solve this kind of problem when the projectile is thrown making an angle theta with some inclined plane. Okay, where angle of inclination is alpha and theta is the angle with respect to the inclined plane. So in this kind of cases, you look at any position on this inclined plane, g will be acting this way, perpendicular to the horizontal. But what about, like, how does this g going to affect the motion of this projectile in this case? Actually it will affect in different way. Look, this way, if this is alpha, this also will be alpha, so this angle will be, so this component along, like perpendicular to the inclined plane, it will be g cos alpha. Okay, and along the inclined plane This will be G sine alpha. Now this whole problem can be actually converted into our known form like this. If you think this is inclined plane now, if this x-axis you say this is inclined plane now, okay, inclined plane, all right, and now this is your velocity u making angle theta, but in this case this g is not constant, so g will be along along the vertical direction g cos alpha, and along the horizontal direction also there will be a component of along the inclined plane, this is g sine alpha, g sine alpha. Now with this concept you have to solve the problem. Look, we'll just try to solve this problem. Let me just go to an empty page. So here I have got some good space. Let me redraw the figure. Now you know you have u cos of theta as it is in this direction. Okay, when you have u like this, now this x-axis is an inclined plane, so this way there will be g sine alpha just against the horizontal motion, there will be component of the gravitational acceleration. Now in the vertical direction you have velocity component u sine theta, and you have g as u, so this is not theta, g has certain, okay, so inclined plane has angle this alpha, okay, so this is cos of alpha. Now look, we'll do the derivations as usual. So we know we have to find out the time of flight. How to do that? Time of flight, you can find out, first you find out the time it takes to reach up to the maximum height. So that can be found out how? You just consider the vertical motion. So if we consider the vertical motion, then look what happens. So in the vertical direction, at the maximum height, I'm just trying to derive the formula for the range. Okay, maximum height, velocity will be 0, v will be 0. So by doing that we can find out, 0 is equal to u minus g, here g is not g is g cos alpha into t, suppose yeah, so this is equal to 0. So what is t then? What is the time it takes to reach up to the maximum height? That is small t is equal to u. Now this u is not u, this is u sine theta along the vertical direction, u sine theta divided by g cos of alpha. So we have got the time now. So what is the time of flight then? We have to multiply 2 with this. So time of flight will be 2 into small t, that is equal to 2 u sine theta divided by g cos of alpha. Okay, let it be there. We are not putting the values right now. Let us first find out the formula, then we'll put it there directly. So now you have to find out the horizontal displacement, so that can be found out now. See, by u cos of theta into t minus, because this g is actually against the motion of the projectile in the horizontal direction. Now it is not a constant of motion, it is actually under deceleration. You can see that under g sine alpha deceleration. So ut minus half g sine alpha into t square, this t square. So we can find out u cos of theta. T is u 2 into u sine theta by g cos of alpha minus half g sine of alpha into t square means 4 u square sine square theta divided by g square. So 1g I can cancel out. So let me write g, and this will be cos square alpha. Cos square alpha. Okay, so now if we do little bit of simplifications, what we get 2 into u cos of theta sine theta. Let me write this as u into sine 2 theta sine 2 theta divided by g cos of alpha minus this 2 goes with this. Okay, so there will be 2u square sine square theta into divided by g into tan alpha, no, not tan alpha, the sine alpha divided by cos square alpha. Let us just keep like that itself, because we know the angles we can find out. So sine alpha divided by cos square alpha. Now if we put the values, see u was actually 2 meter per second, theta was 30 degree, and alpha also was 30 degree. Now let us put the values. So see, u is 2 meter, sine 2 theta, that means sine 60 degree. Sine 60 degree is actually root 3 by 2, and this is g has been asked to take 10, and g cos alpha means again cos 30 degree means root 3 by 2, root 3 by 2, and this will give you, see, u square means 4, so 8 into sine square theta, that means again 4, because sine theta, sine 60 degree means half, so this will be 1 by 4 divided by 10, and here again sine alpha is half, but this is 3 by 2. Okay, root 3 by 4, 3 by 4. Okay, so if you solve this, so this will be getting cancelled, so it is 1 by 5 then, and this would give you, so okay, so this goes off, so there here will be 4 by I think 30. Okay, so we can further simplify 2 by 15. Okay, now these are actually, so let me, so 3 by 3 minus 2 LCM if we do by 15, so 1 over 15, it is 1 over 15. So this is meter in meter. Now if you multiply 100 with this to make it, so to make it centimeter, so 5 3 and this is 20. Okay, so I think there is, okay, so 2t by sin. Okay, so this is the way we have to actually calculate. If you put all the values correctly, all of them correctly, then you should reach it to something like 27 centimeter, but I might have done some calculation error here. Okay, so I'll just summarize what I have done. The process is perfectly correct. So here one thing you have to remember that, so this will be the answer actually, 27. So here you have to remember this thing, that G is not constant. So you have to break the component of the G as you do in case of motion in inclined plane, and then you have to see whether there is effect of G even in case of horizontal motion also. So that's the main point over here, so which you might have uh, remember, or you might be just noting that particular point. Okay, so now we'll move on to the next question. So this is also a very important problem. This is also related to projectile motion only. So a body is projected at t is equal to 0 with the velocity 10 meter per second. So 10 meter per second here, and the angle of projection is 60 degree with the horizontal, and the radius of curvature of its trajectory at a point 1 second is r, that is given. Neglecting the air resistance and taking the acceleration due to gravity g to be 10 meter per second square, you have to find out the value of r. So what is the problem? Problem is that a projectile has been projected at an angle 60 degree with velocity 10 meter per second. So this is all right. So this is as usual, no problem with this. Now you have been given that after t is equal to 1 second, t is equal to 1 second, this projectile has a radius of curvature of the trajectory. Radius of curvature of the trajectory is given, and that is r. You have to find out the value of r. What is that value of r? So to solve this problem, you look more or less our trajectory is kind of this parabola. So what we have to do is we have to find out what is the angle velocity makes with horizontal velocity, total velocity makes with the horizontal after t is equal to 1 second. That is the crucial point here. And at that particular angle, g will not be just a constant along the center, or towards the center. Here, look, r is given means at that particular, after t1 second, after t1 second, the acceleration towards the center we will find out. So that is actually v square by r. This is a clue. And what is v square? V square is the total velocity as you see in this figure at this particular position. Now we can be able to find out theta by writing vy by tan inverse vy by vx. Okay, vy by vx. So theta will be obtained. So this thing is exactly equal to actually uh, the acceleration towards the center. Okay, so that is g cos theta. This is equal to g cos of theta. Okay, so from here r can go here. So from here you can find out r is equal to v square, the total velocity, magnitude of the total velocity divided by g cos theta. Okay, so you need to find out what is theta. Now the angle 60 degree is given here. This is not the angle I am interested now. The angle after t1 second. That means what? You have to find out the velocity components along x-axis and y-axis after t1 second. So let us do that. And while doing, again I'll explain what I am doing. See, I have to find out velocity components after velocity components after t is equal to 1 second. Okay, after t is equal to 1 second. So these are my aim first. Okay. So what is the velocity? Velocity is 10 meter per second. So I have two components initially. So 10 um, cos of 60 degree. Cos 60 degree means half. So horizontal velocity ux, we have got initial velocity to be 5 meter per second initially. Okay, and now uy initially how much? Sine 60 degree means 10 into root 3 by 2, so 5 root 3. So these are initial velocities. I have to find out the final velocity. Anyway, here if this goes in this way, so g is constant. Okay, so this horizontal velocity will be constant. Okay, horizontal velocity will be constant since it is not in inclined plane. So that is fine. Actually, if we just consider the velocity of this particle, uh, horizontal velocity, that is remaining constant actually. That is 5 meter per second. Only thing is the vertical velocity is under gravity. So we can find out Vy is equal to Vy. Since t is given, we can find out Uy minus of g into t. G has been asked to take 10 meter per second and t is equal to 1 is given. So Uy is 5 root 3 minus 10 into 1. So you get actually 5 into root 3. Okay, so or else let us just keep like this. Just let us keep like 5 root 3 minus 10. Okay, so this is the velocity after t 1 second. So if we take the modulus, let us take the modulus of that. Okay, let us take the modulus. So if we take the mod of this velocity, we can write this as this. We are just taking the mod, and mod of x is what? Mod of x we know after t 1 second. So mod of the velocity is just magnitude of the velocity. We have got magnitude of the velocity along vertical direction 10 minus 5 root 3, and along the x-axis it is 5. So these are meter per second. Now look, as I said, we have now reached where? We have reached after t is equal to 1 second. We are not no longer at the origin. We have reached somewhere at this particular position. So after t second, when we reach this position, then what is the angle the velocity is making with the horizontal? So that we can find out by doing this. Tan theta is equal to modulus of Vy divided by modulus of Vx. So let us see what is that. So this will be 10 5 root 3 divided by 5. This will be 2 minus root 3. So if we just take theta is equal to tan inverse of this quantity, this is around 0.27, which is giving nearly equal to 15 degree. Okay, nearly equal to 15 degree. So we have got what is theta. Now look, it is said that the radius of curvature is given, and see at this particular position, since this is making an angle theta, this G at this particular position, this G will not be like G is there in the along the horizontal direction, it is G, but along the center, towards the center, what is the acceleration due to gravity? So acceleration due to gravity towards the center of this curve, actually not the center of earth. Acceleration due to gravity, because that is the acceleration which is giving. So if I just take like this is a nearly circular kind of that, if we just consider, then this G cos theta, if this is theta, this also will be actually theta. So this G cos theta is actually giving us the necessary centripetal force or centripetal acceleration. So acceleration due to gravity towards center of the curvature, towards center of the trajectory is G cos of theta. That means G cos of 15 degree. Okay, so this is what we have come to know. Now see what are the information we know now and what we can do with this. We know the G. So now look, we can write as usual, we can write acceleration towards the center of any curvature will be v square by the radius of curvature. Okay, so what is this v? V is velocity, total velocity at this particular point. So what is the total velocity? Vx square plus v vy square plus vx square, or vx square plus vy square divided by r. Okay, so this is the thing here. Okay, now look, I'll just take a note here. I know that I have to keep this velocities anyway. Theta is 15 degree, we have already come to know. I'm just rubbing this out. Okay, okay, clean. Okay, so now this portion I will be using. So vx square plus vy square, so total v mod of this v square. So this is actually vx square plus vy square. Okay, this is what we have to find out. So if you just put these values vx and vy, it will actually give you something like, see, vx square means 25. Okay, then vy square means this, then plus 75 minus 2ab, so 10 10 100 root 3, 100 root 3 here. Okay, so this is the thing. Okay, now if we put it here at this particular position, and again I have told you AC is G cos theta. Now AC is G cos theta. With this value we'll be able to get the value of R. Okay, so let us, so R is equal to V square means 25 plus 100, so this will give 100 and 200. Anyway, this is 200 minus 100 root 3 divided by A is G cos of 40, sorry, 15. G means again how much? G means 10. So you will get actually 20 minus 10 root 3 divided by cos of 15. And you look, if I just take 10 off over here, then it will be 10 common. So 2 minus root 3 divided by cos of 15. So this will actually get cancelled. Okay, so this will get cancelled. Okay, let me. So this is 200 anyway, 200. So I can take 100 common. 100 common. Let me. Let me just take here write 10 itself. So 200 100 common. 2 minus this divided by this. So let us just do this calculation. So 10 into here cos 15 will be there, cos 15 degree. Okay, so yes, cos 15 degree is not the value of this. Anyway, this will be giving you tan 15 degree. Okay, so 10 into this factor, 2 minus root over 3. So root over 3 means 1.73 you can use, and this is 2. So if you just take this out, then multiply with 10, you'll get 2.6 around. And if you just divide with cos 15, then you will be reaching to some value like 2.77 meter. So which will be nearly equal to 2.8 meter. Okay. So this will be the answer. I hope you have understood the process. Now the calculation part up to you. You just see how best you can do with the calculation part. So this will give you 10 here. This goes, and this cos 15 degree. You have to find out the value of this, or you can either remember such kind of values, or you have to use some tricks. So to find out this cos 15, so you get 2.8 meter is the final answer. So this radius of curvature will be 2.8 meter. Okay. Now these are today's these problems are mainly on projectile motion, but these problems are really tricky and thoughtful problems. That's why I'm just discussing. So here in this problem, there are two guns A and B which can fire bullets at 1 kilometer. So let us say one U1 is 1 kilometer per second, and another gun can fire a bullet at the speed of this. Okay. Now from a point on the horizontal ground, they are firing in all possible directions. Now the ratio of the maximum area covered by the bullets fired by the two guns on the ground is what? See, we will be actually considering this to be a circular nearly circular trajectory for the time being. And somehow, if we can find out the range, okay, range, if we can find out, then it will be easier to like that. Then you can find out the area, pi r square. If you know the range, pi r square by 4. Okay, so that will give you the area. So look, in this case, maximum, if you want to get maximum area, then your range should be maximum. And see, range should be maximum. R max will happen only when, see, we know R is equal to U square by sine 2 theta divided by G. So range will be maximum only when you have, so this will be U square by G only when you have theta is equal to 45 degree. So we have got this clue that both of them have to actually fire at 45 degree angle. Okay, 45 45-degree angle. Okay, so if they fire at 45-degree angle, what is R1? So R1 will be U1 square by G, and R2 will be obviously U2 square by G. Okay, these are the suppose these are actually the diameter kind of that you can find. You can just think of approximately this is a circular approximately. Okay, now you have to find out the ratio of the area they covered. So area, I take ratio pi r1 square by 4 and pi r2 square by 4. So these are the area. So pi and 4 will go off actually. So r1 square by r2 square. So this will give you r1 square means u1 to the power 4 divided by u2 to the power 4, because g will get cancelled. And these are, since these are in ratio, I don't have to go for meter and all, units will be taken care. So it will be 1 to the power 4 divided by 2 to the power 4. So this is 1/16. So the maximum area, the ratio of the maximum areas covered by these bullets will be actually 1:16. Okay, so this is how you have to get the clue. So when they are telling you about area and all, you have to just take the trajectory approximately circular, or yes. So that is the clue, and the range has to be taken as the diameter of the trajectory. Okay, so in that way, if you think, then maximum range can be possible only when theta is equal to 45 degree. So by doing that, you can find out the range for both the bullets, and from there you can find out the areas covered by them and take the ratio. Okay, so that's the way. Now we have another problem. This is also related to projectile motion. So a shell is fired from a fixed artillery gun with an initial speed u, such that it hits the target on the ground at a distance r from it. If t1 is the t1 and t2 are the values of the time taken by the bullets to hit the target in two possible ways hit the target. That means what? If suppose there is a target over here, okay, so your range, in both cases the range has to be the same. So if I say one is at an angle theta and another one has to be fired at 90 minus theta, so both cases the range will be the same. So let me tell you, range is u square sine 2 theta by sine 2 theta by z. Look, if I put theta, then this is the range. If I put, suppose this is r1 and this is r2, u square, anyway velocities are the same from both angle, sine 2 90 minus theta if I put. So one has to be actually projected at theta angle, another one has to be projected at 90 minus theta. Then what will happen? You look here, sine 180 degree minus 2 theta. So this is also will give you sine 2 theta only. So u square sine 2 theta by z. Okay. So the range will be the same from two certain angle. One is at theta, and if another one is projected at an angle 90 minus theta. Okay, now we have got this idea. You have to find out the time. So t1 is what? T1 means, see, one has velocity along the vertical direction u cos of theta, and another one has velocity u cos of 90 minus theta. Sorry, this is sine. another one sine 90 minus theta. So let me tell you. See, in case of theta, you have vertical velocity u sine theta. In case of 90 minus theta, you have u sine of 90 minus theta will give you u cos of theta. Okay. So in case of, suppose the t1, I'm taking, so t1 will be actually u by g. U by g means u sine theta by g. Okay. And t2 similarly will be u cos of theta by g. Okay. So these are the thing. So now we have to find out what is the t1 t2 product t1 t2. So product will be t1 t2 is equal to u square sine theta cos of theta divided by z. So if you want to make it, so if you want to write in terms of r range, then what you could do with this? So okay, so let me see. V is equal to, oh, I see. You have to multiply it with 2 because it has reached over here. So 2 you have to multiply both cases. There should be 2 2 because this is that these are the time of flight. Okay, time of flight. So 2 has to be multiplied. So here will be 4. 4 means you look 2 sine theta cos theta we can write. So u square let it be. Then 2 into sine 2 theta divided by, so there are 2g, so g square, it will be g square. So g square, that means what? So u square sine theta by g, I can write that as r. So 2r by z. So this product will be actually 2r by z. So this t1 and t2, these times are actually the time of flight. So that's why you have to multiply 2u sine theta by g and 2u cos theta by g according to this. Okay. And then if you multiply, then you will get 2 into range by z. So 2 into range. Oh, I'm sorry. These options are actually somehow copy pasted. I'll give you the real options. What are the options? So first option was r by 4g. Second option was, these are not correct. Second option was r by z. C, option C is giving you r by 2g, and option D is giving you 2r by z, 2r by g. So see, this option is the correct answer for this question. So these are not the correct options because somehow these are copy pasted, or all of them are equal. So these are, so r by 4g, r by z, r by 2g, 2r by z. So these are the options. So we have found out. So what was the clue here? The clue is that the range will be same for two angles of projection. That is, one is theta and another one is 90 minus theta. So this point you have to remember. Then you find out the time of flight for both of them using theta and 90 minus theta in the particular expressions. If you put, then you will get the t1 and t2, multiply them and try to get in terms of range. Okay, that's how you get to r by z. Okay, so we'll stop it here for today. Next day we'll start with the laws of motion, and we'll take a few more problems from this laws of motion as well. So I'll stop it here for today.